First up, we have Bernhard Gleissner. Try to get it very high up and especially looking the right direction. I think that's good, yeah.
Is that good?
No, that's just going to flop, so that's...
You help me? It's on now? Yeah, you can hear me. That's good.
Okay. So finally, we have Bernhard Gleissner, who is going to talk about the high-performance FPGA solutions from proDesign. So Bernhard has a master in electrical engineering and was an early bird at NVIDIA in the year 2000 as their vice president of Europe, Middle East, Africa, and India. And now he is heading the high-performance computing business at proDesign. So thank you, Bernhard. The stage is yours.
Thank you for the nice introduction. Honestly, I could speak here for hours about when NVIDIA was a startup, which would be interesting for all of you, yeah, because it was amazing time, yeah, in 25 years ago, how small NVIDIA was and what has become out of it, yeah. But that's not my job today. So honestly, when I'm coming to CERN, I always learn something amazing. For example, that the Higgs boson has been found here. Or I was yesterday at a factory tour that you produce antimatter here. Unbelievable, yeah? Or I heard, and I'm not sure whether it's true, that you made gold out of lead, yeah? It just stayed gold for a couple of milliseconds, but at least you did it, yeah? So the big question to me was, what do I tell you guys? Here are all the geniuses, the smart and clever guys. And I'm an EMS company, yeah, with proDesign. But I thought, so maybe let's work my age a little bit for me. So who in the audience is older than 60 years? What's your name? Richard. So Richard and myself are older than 60 years. And Richard and myself grew up in a time where the rock and roll music just became an element of the world. Yeah? And Richard and myself, we grew up with AC/DC, Deep Purple, Pink Floyd, Rolling Stones, you name them, yeah? Deep Purple, yeah? And so I want to tell you a story, a true story, which you maybe don't know. Richard and myself know, but maybe you don't, yeah? So here, since we are at Geneva, at the Lake of Geneva, yeah, there was on the other side, not on the Geneva side, but on the Montreux side, on the other side of the lake, there was a big music studio. And next to the music studio, there was the Casino of Montreux. And a lot of these big famous rock bands went to this music studio in order to cover their next record. And in 1971, so we were born, yeah? In 1971, Deep Purple went to the music studio in Montreux, and in the Casino of Montreux, Frank Zappa. Richard knows, I don't know who knows Frank Zappa, Bobby Brown, okay, good. So Frank Zappa had a concert, and during the concert, one of the fans shot a signal gun just because he was excited, and the whole casino burned down to the ground, yeah, in Montreux. And Deep Purple was in the studio and seeing the casino burning, yeah, and seeing the fire in the sky. And then they looked at the lake and then they saw smoke on the water, yeah? And that's really true. The song from Deep Purple, Smoke on the Water, was invented in Montreux at the Lake of Geneva because the casino burned down. So if you don't learn anything out of my presentation, at least you learned something about rock and roll music. Yeah? So, but let's come to my presentation. So, proDesign is located in Germany. So we are a German company, south of Munich. And when I show that picture normally in a presentation, I'm pretty proud that the location is so cool. Yeah? So you see the Bavarian Alps in the back. We have an hour to Austria, we have 2 hours to Italy, all the ski resorts are there, the lakes and everything. Unfortunately, this doesn't work here in Geneva because you have the Swiss Alps. You have Switzerland and France. You have the lake. You have Zurn. So how can I impress you guys? So this slide doesn't really work, beside the fact that in Bavaria there's the much better beer. Yeah? So that's the big thing I can put here. Yeah? We have 100 employees. It's a mid-sized company. 15 are engineering, in the engineering department, hardware and software guys. 15 people are in the test and inspection center. 25 are in the manufacturing, on the manufacturing lines, and the rest is administration. When I was first time here at CERN, I was meeting Nico Neufeld at LHCb. And yeah, we were just sitting down, and his first question was, how was your trip? And the second question was, what volume do you expect? That's always a question I have here. Yeah? And so don't worry, our business model is specialized on prototyping volumes up to, so that is 3 or 5, up to 50 or a couple of hundreds. So that's where we are specialized. We have optimized our production that we can switch pretty quickly from one product to the other, and that's our specialization in that case. We have an own product line, which is really based on high-end FPGAs. We have done in the past, we had our own product line, which was a prototyping system called ProFPGA. And that meant we had 20 or 30 of the actual biggest FPGAs combined, that the array of logic elements is getting as big that the big companies like NVIDIA, like Apple, like Intel, they can simulate and prototype their next ASIC generation. So this our company has done, and we sold that division just a couple of years ago to Siemens Mentor because they had the software, we had the hardware, now they can offer everything. We still manufacture the whole stuff, but the development is in the hands of Siemens now. And so we decided, so what's next? And we have a 30 years experience in FPGAs. So we said, okay, the HPC market is huge. Let's have as a new product line, own product line, PCI Express-based FPGA acceleration boards. 4 different segments: internet security, live video broadcasting, and. Yeah? So this is our own product, but I would say at least 80% is the manufacturing and the development we do. So I said already, electronic engineering and manufacturing services. What is that a little bit in detail? As I said, we have an engineering department. These engineers do schematics, do all the electronics of a board. We have layouters. They do the layouts of the PCBs. Here I have to say the maximum number of layers we have done a product was 52 layers. So that is 5 millimeters. Doesn't fit into a PCI slot. So we have a special technology that we shorten the thickness of the slot portion of the PCB. But that's what we have done. Of course, we have mechatronics engineers, so we do housing, we do special cooling systems, we do passive coolers, which are just upside down, fitting exactly on a motherboard, that they don't touch the motherboard, but that they have enough surface. We do simulations and verification in our process, in our factories. We have SMD lines, but the engineers are capable to handle nearly all of your projects and demands. If you say, I need help, I need some help in designing something or some experience. The next is the production. We have a production area of 2,000 square meters. We have SMT, we have THT lines. very small, we can handle with so we just upgraded one of our SMD lines to the highest end Cplex from SM8 PT. And they can handle 0.1, 0.05 components, just that you have an idea. Such a component is not thicker than a hair. Yeah? And when you see that, how they position and place all these components on the machines, it's unbelievable. Just for you, first you do the back side of the board with the smaller components, and then you turn it around and put the upper side with the bigger components, because they would fall down sometimes. Yeah? So that's an idea. We handle FPGAs up to 7,000 balls, which is massive. And we have also two rework stations where we can take off from the board the FPGA, reball it, and use it again, because sometimes the board is broken, but the FPGA is more expensive than board. So we have these rework capabilities in our house. Yeah, the question here was also very often at CERN, how is the size you can manage? So we can manage 620 to 535 millimeter PCBs in our assembly machines. We have microscope workstation. We can do 3D print, which helps a lot with air guides and all of that stuff if you have to do special coolings. We have a mechatronics department, I said already. We do housing and we do special cooling things. And we have a customer which is into cameras. And for the special lenses, you need a kind of clean room for the cameras. We have also that in our production facilities. Test inspection is also very important to a lot of customers, because many of them don't have the resources to test every board for 3 or 4 hours. And that happens. Some boards just need a test for 5 minutes. That's fine. But 4 hours, that means resources. So we have developed with a lot of customers special test routines and designs, which we do in-house. And when a board leaves our manufacturing, our facilities, it is fully tested and nobody has to worry about it anymore. We have optical inspection. We even do X-ray the boards. And believe it or not, we got FPGAs in the past. And during X-ray, we found out there were shortages inside the FPGA. So you can't see that, yeah, if you don't X-ray. And you don't X-ray if you haven't had the problem before. Yeah? So think about that. Sometimes the FPGA just has a problem. I said the test concepts, I said, yeah, and then we do a full documentation and full traceability. So this is a very important part of our company and an important service we offer. And I'm very proud my son is in that department since 3 months back from university. So that's pretty cool. This is an own product line where we started. So this is a high-end FPGA PCIe accelerator based on the Stratix 10 from Altera. You see on the left side, you see 4 cages. Each cage can do 200 gigabit per second. Then we have 3 SODIMM modules, connectors on the board, which are programmable. Also, the voltage is variable. You can program the voltage per SODIMM. That is not just usable for memory, but also for any kind of daughter card or whatever you want to add to that board. And we have 3 high-speed connectors on the right. You see the golden ones. This comes from our prototyping system. So instead of letting all the boards, if you have more in a system, communicate via the PCIe bus, you can connect them directly and let them talk to each other. So this is the actual board, which we sell into several markets. I give you an example in the next slide. The follower is already in development. It's based on the Agilex 7M. It has 3 times, the plan is to give it 3 times 400 gigabit per second. And there are segments in the HPC market which need this high bandwidth, yeah? Especially the video broadcasting segment, the live video broadcast segment, where you are at concerts, soccer matches, Olympics, whatever, tennis matches, yeah? Where you have a lot of cameras installed around the arena, in the arena, and wherever, yeah? and all these feeds, all these cameras needs to go into a system where the regisseur decides per camera what is broadcasted. Camera 1, then switch to camera 4, put an advertising in, go to camera 7. So that all happens in these huge trucks you see aside of these kind of concerts or wherever. So, and in the past, that segment was dominated by CPUs. CPUs, the code was written on CPUs, and you had for such an event, you had a rack of 15 to 20 U, all with CPUs doing the job. And we decided, together with a German company who writes the application, to develop a 1U server who can do the same. A 1U server who has the I/O bandwidth, who has the low latency of an FPGA, and who has the power of an FPGA, because we saw a problem. These trucks are not that, they have a lot of other stuff inside, so let's save some space here. And this was the product which we developed together. This is a server, and you see 4 of these cards on the right side. So 4 times 4 is 16 by 200. You have 3,200 gigabit per second I/O bandwidth, which is a lot, yeah? Which is exactly what this huge CPU-based rack did. So we solved the space problem. Second was power consumption. In these trucks, you don't have endless power. Yeah? So we solved that problem because this whole server just needs 1,300 watts. That's it. Yeah? So we solved space, we solved power consumption, and of course the price of such a server compared to a 20U rack of servers, we also have a much better price, and I would say this kind of product was disruptive, yeah, in that market segment. And so we are always ready to think about problems and help solving problems. This is a new baby which we have in our portfolio. This is based on the microchip PolarFire chip, and it is an 10G fiber input and output, and you can put in whatever protocol you have. The protocol converter is done inside the microchip FPGA, and it gets out Ethernet, and then you do something, and the other way back also re-protocol it to the protocol you want to give it. Very small, very efficient. The cable you see here is a JTAG connector where you can directly program the FPGA, but in mass production you take this off and you can also program the FPGA via the I2C bus. Yeah? So this is 10G. We have also a request for 1G copper, and this is where we are working at the moment to do a similar product because the market, the overall market, maybe not here, but the overall market is still 70 to 80% is 10G, is 1G copper, and then it just goes to fiber in different segments. So developed by our engineers and available at proDesign. Just a couple of words about the segments where we are. So we have developed products for the financial trading sector. We have a huge German customer for the medical imaging processing and high-end microscopy. That's the same, by the way. We do semiconductor assembly. So these cameras are used for semiconductor assembly just to check whether something is wrong or right. And we have this clean room in-house. I have here a picture of particle physics. This, I think, is a Max Planck product we have done, which is used in the Atlas experiment. And the ASIC prototyping, I spoke about it. This is how it looks like. It's just a modular concept of connecting up to 30 huge FPGAs and make the array of logic elements just as big as you need. Yeah? So this is 2 projects we have done here at CERN. It was at CMS. It is data acquisition cards. We have not developed these boards, but CMS, we won the production of that 2 cards, and a couple of more are in process. So to my presentation, what you should remember, yeah? If you need electronical help in defining schematics, layouting, whatever, this is the only message. Think about proDesign. Think about us. Yeah? And to close the loop where I started, if there is electronically spoken fire in the sky or smoke on the water, yeah? Think about proDesign. My name is Bernhard Gleissner. This is my email address. Touch base with me. Thank you very much. Now,